In a previous quest, you guys learned that in a triangle, if you add up all three angles, it's always going to equal a sum of 180 degrees. And a triangle is the most basic polygon that we can make with the three sides. Because a polygon, remember, has to be closed. So if you just had two sides, you basically have what looks like an angle. Okay, so a triangle is our most basic polygon, and we know that the three angles are always going to add up to 180 degrees in a triangle. So we're going to use that fact to help us investigate the angle sum of really any polygon, no matter how many sides it has. And there's going to be a nice little formula at the end of this assignment so that we can, knowing the number of sides a polygon has, we can find out instantly what the angles are going to add up to. Okay? So the way that this investigation is going to work, let's go through these questions here, 1 through 4, and then I'm going to leave you. I might just kind of lead you through some of the questions, what it's asking, and then you will need to fill out like this chart here and answer some questions. Write a sentence explaining. So again, we're trying to look for some logic. Please use full sentences, and then the part 2 goes into regular polygons. So let's take a look at these first questions. What is the interior angle sum of triangle ABC? Well, we know. I'm just going to zoom out a little bit so I can look at the questions and the pictures. Okay, so we know that in this triangle, the angles are always going to add up to 180 degrees, right? So this is 180 degrees. Okay, now, what is the interior angle sum? Or is the sum of the interior angles always the same? Yes. Right? It's always going to be 180 degrees. Our reasoning for that is that parallel line construction in rotating this angle to come up here, rotating this angle to come up here, and they equal 180 degrees, right? A straight line that's parallel here. That's what parallel. Whenever we see lines or segments that are parallel, we use these little arrows to denote parallel. So yeah, they're always going to equal 180 degrees. These three angles will always equal up to a line, right? 180 degrees. Oops. So what is the sum of the interior angles of this quadrilateral? So here's how the investigation is going to work. What I want you to think about is drawing diagonals in a polygon so that we can create triangles, because we know the interior angle sum of a triangle. It's 180 degrees. So drawing a diagonal, there's two diagonals in a quadrilateral. Just draw one of them. So I could draw a diagonal DF, right, that line right there, or EG. That's another diagonal I can choose. Choose one, and it doesn't matter which one. Maybe I'll do DF. So what is the interior angle sum? Well, we have one triangle here now, right? And we know that the angles, if we add up this angle plus this angle plus this angle, don't they equal 180 degrees, right? Well, there's a lower triangle in this picture as well. So this one right here, if we add up this angle, and this angle, isn't that also 180 degrees? So if we add up, this red angle and this blue one really just make this angle F of the quadrilateral. Same deal here, right? Those two really make angle D. So add up this angle, this angle, this angle, this angle. Looks like they're going to be the sum of 180 plus 180, or 360 degrees. So the angle sum of this quadrilateral is 360 degrees. And really, any quadrilateral, like if I draw a quadrilateral, wow, that looks, say, like this, as long as I draw a diagonal in, notice we get two triangles, 180 degrees sum here, 180 degrees sum here, so all the angles will add up to 360. So to answer number 3, it's 360 degrees. Is the interior angle sum of a quadrilateral always the same value? How do you know? Yes, it is. How do we know? Because when we draw in one diagonal, we always get two triangles made, and their sums are always 180. So yes, in a quadrilateral you get two triangles, so all these angles always add up to 2 times that 180, or 360 degrees. Okay, so that's going to be how this investigation works. So the part 1, please read these questions carefully. Look at the segments that they talk about, like segment EG. All right, and it's going to talk about what we just did. I want you to go through this. So the measure, whenever you see M like this, it means the measure of the angle, meaning we want the value of it, like 30 degrees or whatever it happens to be. Okay? So work through this assignment here. So in the procedure, you're going to do this same procedure every time. Let's say, for example, you get in the chart. I'm just going to do, say, a hexagon. Here's how this is going to work. So when it says select one vertex, so let's talk about hexagon. Sketch a polygon. So I'm going to sketch a hexagon. 1, 2, 3, 4, 5, 6. Always draw a concave one. Okay, now draw the possible diagonals from that vertex. So if we choose a vertex, there's 6 points here, right? This one, this one, this one, this one, this one, or this one. Choose one. And it doesn't matter which one we choose. Maybe I'm going to choose this guy. Okay? From that diagonal, from that vertex, draw as many diagonals as you can. So diagonals are just points or segments that connect non-adjacent points. So from the one diagonal that we chose, I can only, in a hexagon, I can only draw 3 triangles or diagonals. But notice now, once I drew those diagonals in here, we have 1, 2, 3, 4 triangles. And all these angles in each triangle have the same sum of 180 degrees. So we can use that fact to help us understand, even in a hexagon, what all the angles would be. And it's all based off of triangles and that 180 degree angle sum. Okay? So if you had, say, a pentagon or a heptagon, just draw the shape, choose a vertex, and from that vertex draw as many diagonals as you can, and then look at how many triangles you get made. And as you do that, you're going to be filling out this chart here, right? Number of sides, number of diagonals, number of triangles, and the sum. So this will help us organize. When you get to the n-gon, this is going to be, hopefully in this box here, will be our little rule or formula based off of the number of sides. So you're going to ask you, what do you notice in the table? What kind of patterns do you see? And then it's going to ask you to write a rule, or at least explain in words, like a sentence, how to find the interior angle sum, okay, of any polygon. So n sides is just a variable. N could be 5, then we're talking about a pentagon, right? A 5-gon would be a pentagon. N could be 10, then we're talking about a 10-gon or a decagon. N could be 20, so then we'll be talking about a 20-gon. So in this table, you'll see a nice pattern. Try to generalize that pattern if you can. Okay? And then as you get through that pattern, it's going to ask you part 2. Now we're going to talk about regular polygons. So regular, remember, all these angles are going to be the same. So it's all about division. Take the sum of the interior angle sum, divide by how many angles there are, and that'll give you each one. And you get led through that example here. Okay? So, go through this assignment, do what you can. Please submit this to me. I know that there's 7 pages, so remember Metamoji, you're going to have 7 picture files. You could either send them through 3D Game Lab or maybe do this on paper or a Word document and have each picture on your Word documents. However you choose to get it to me, make sure I get all pages on here. All right? Good luck with that investigation, guys.